All right, we're going to start with just sets of numbers. That's what we started with in chapter 1. These are your sets of numbers: natural, whole, integer, rational. And then you also have that little set irrational that's over to the side, and they're all part of your real numbers, okay? One way to look at it is just a list. Natural numbers 1, 2, 3, 4, 5. Whole adds 0. Integers add your negatives. Rationals is anything that be written as a fraction. Irrational, non-repeating, non-terminating decimals. Real is all of them. Another way we look at it was like this. Okay, so this kind of gives you a Venn diagram of it. When you look at it this way, you can see how they kind of fit into each other. Your natural numbers, well, that's just the counting numbers you learned when you were in, kindergarten, 1, 2, 3, 4, 5. And then whole numbers, well, that includes all of these natural numbers, and it adds 0. So whole numbers include 0, and then everything in natural. Integers throws in your negatives, but it also includes all of these whole and all of these natural. Rational, that's anything that can be written as a fraction. So the reason your whole numbers and natural are in here, because 3 as a fraction is just 3 over 1, okay? So that's your rationals, anything that can be written as a fraction. That includes repeating decimals, 1/3, that's a repeating decimal, right? 0.3 repeating. All right, and so it includes something like that, or includes regular decimals, 1.25, and any negative numbers as well. The only thing rational doesn't include is your irrational. Those are your non-repeating, non-terminating decimals. Pi is always a great example, right? 3.14, and then it goes on infinitely. And then square roots that do not have a perfect root. So like square root of 3, square root of 7, square root of 5, whatever, that does not have a perfect root. Those are also going to be irrational. But you'll notice both of these are in this box called reals. They're all real numbers, okay? So if you had to label it, you know they're all going to be real. We haven't even gotten to imaginary yet. That's algebra 2, okay? Real numbers is what we're talking about for anything in here. In the letters, it's natural is just your N, and it actually does this little guy. Whole, that's your W, right? And technically you have that little line there. Integers is actually Z. All right, rational is actually Q. Irrational is I, and real is R. The next thing we talked about in this was just adding and subtracting integers, okay? A few rules for adding and subtracting. If you are just adding two numbers with the same sign, so you'll notice this first guy, two positives, you're just going to add their absolute values, and it's going to be a positive number, like positive 2 and positive 5 or positive 7. If you're adding two negative numbers, you're just going to add the numbers, and the answer is negative. Negative 2 plus negative 5 is negative 7, okay? This is where we get into what happens when you're adding a positive and a negative. Here you're going to subtract, and your answer will follow the larger sign. I found this little schematic kind of makes you visually see it, even though, so the blue is like the plus and the red is the negative. It's harder to see for you. All right, so if you have two that are the same, two positives, that's a positive, two negatives, that's a negative. If you're adding a positive and a negative and your positive is bigger, your answer is positive. If you're adding a positive and a negative and your negative is bigger, your answer is negative. So these situations you're going to add, here you're going to subtract. Okay? Adding and subtracting positive integers. With multiplication, if they're the same sign, same is going to be positive, different signs negative. So you don't have to look at which one's bigger, which one's smaller. You just have to worry about, are they the same sign, are they different signs? And if you have multiple ones that you're multiplying, if you have an odd number of negatives, it's going to be negative. If you have an even number of negatives, it will be positive. So if you're multiplying like 3 or 4 numbers, you can just count your negatives, and you can already figure out what your answer is going to be, positive or negative. So order of operations, often said PEMDAS. PEMDAS, the P represents any type of grouping. So it could be brackets, it could be parentheses, it could be something on top of a division sign. Remember, if you have a division line, everything on the top is grouped, even if it doesn't have parentheses. Everything on the bottom is grouped, even if it doesn't have parentheses. So this parentheses represents all grouping. Do parentheses first, then you do your exponents. Any exponents there you need to do. Remember, if you have a negative, like a negative 2 squared, all right? If it just says negative 2 squared, you technically do the 2 squared first, and then apply the negative. If you're plugging it in, it's like it's grouped, all right? Multiplication and division. Even though in this it looks like multiplication is first, they are grouped, meaning you do all of your multiplication and division from left to right, whichever comes first. So you don't go through and do all your multiplication, then do all your division. You do multiplication and division together from left to right. Okay? That's the same way as addition and subtraction. You do not do all of your addition first and then all of your subtraction. You do addition and subtraction together from left to right, whichever comes first. Okay? That is your order of operations. And that is basically starting on page 3. That's your order of operations. So that's all of chapter 1, or the key things from chapter 1. All right? Key things from chapter 1 there. Let's look at chapter 2. After you simplify, you're going to put all your variables on one side, all your numbers on the other. So first thing to do, distribute if you need to, combine any like terms. Do not do any moving until you can see that both sides are as simple as they can be. Then you're going to say, okay, all my variables need to go to one side, all of my numbers need to go to the other. All right? Which means if I move all my variables on one side, then my next step is going to be addition or subtraction to move my numbers to the other side. So when you're moving across, you are adding or subtracting to move across. You're adding the variables across, you're subtracting the numbers across. Whatever you're doing to move across, you're adding and subtracting to collect the variables on one side, numbers on the other. And then you should have all variables on one side, a number on the other, and your last step is to do division, multiplication, division, depending on what you have. All right, so if you have 2x, you're going to divide by 2. If you have x over 2, you're going to multiply by 2, whatever it is. But you're going to either addition and subtraction to move stuff around, multiplication and division as your last step to solve for what x actually is. Once you've done this, your equation should still be an equation, meaning you should be able to plug your answer back into the original and you should get a true statement, okay? Think of it as a balance. Whatever you move on one way, you don't want to change the balance of the equation. If this is balanced when you get it, then if you take 3 x's away from this side, you must put the 3 x's over on this side, all right? So that means if I'm taking 3 away, I have to take 3 away. So take 3 away, take 3 away. So if I do this, if I'm saying, okay, take 3 x's away here, I need to take 3 x's away here. That's going to leave me 2 x's, right? And then I still have this 1. I have no x's here, and I still have a 5, right? And then if I move the 1 over, I have to subtract him here, which means I need to subtract 1 from here. So he's gone, I subtracted 1, and I have a 4 now. And then my last step is going to be to divide by that 2, okay? So as you're moving stuff across, you have to think about what will take it away from the side that I'm trying to get rid of it on, do the same exact thing to the other side. So the only time you're using the opposite is when you're moving it across that equal sign. If you are simplifying, you're not doing opposite yet. Only when you move it across are you simplifying to do the opposite.